Hello, everyone. Welcome back. This is Cureton, Senior Journalist from XR Today, bringing you the latest and greatest from VR, AR, and XR industries. Today, we will be speaking to Mr. Rashid Mansoor. He is the CEO of Metagravity Solutions. Rashid, it's a pleasure to have you here. Thanks for joining.
It's great to be on, and thanks for having me on, Demond. Great to speak to
Excellent,
everyone.
excellent. So, we're going to go ahead and we're going to jump straight into the conversation based on, what your company does and, what kind of solutions they create for metaverse companies and metaverse experiences. So could you tell us a little bit more about that?
Yeah, absolutely. So Metagravity was founded to solve a very fundamental problem right now in our aspiration for the metaverse. Games today are relatively limited in their multiplayer capabilities. You can have maybe a couple of hundred at a stretch if you relax some of the constraints in terms of players in a game. And there's a limited number of AI, limited number of interactions you can have in such a world. And game designers work within this sort of computational budget to design an experience. And that constraint sort of governs everything that you sort of see in the industry. But the future of gaming looks to be much more social and much more network intense, you could say. And that capability doesn't exist today in terms of the engine technologies, the server technologies, the networking code. And Metagravity is building that infrastructure to make those kinds of games possible. And that's an important catalyst for enabling the metaverse. If we think of the metaverse as a 3D spatial analog of the internet, an internet 2.0, if you will, then that there needs to be radically new backend infrastructure to make that feasible. And Metagravity is working on solving those problems to make these hyperscale virtual worlds and so on possible for the metaverse.
Right. Brilliant. And we sometimes refer to this as like serious gaming technologies or can you hear me now?
Yes, I can.
But
Yes.
we sometimes refer to this as like serious gaming technologies, which basically allow people to, receive top quality cloud streaming or other kinds of infrastructure that is put into the metaverse platform. So that way people can get optimized metaverse experiences. So yeah, great conversation on that. And yeah, we're looking forward to seeing a little bit more from Metagravity to like, dive deep into the solutions that you have. So for the first question, I would actually ask you a little bit more about this. What do you think is the importance of serious gaming technologies, and how do they help to tackle some of the most challenging issues linked to building and developing the metaverse?
Yeah, absolutely. And that's a great question. I think the way I like to think about it is gaming technology is starting to break out of the industry and enter the broader, wider world, I would say. An obvious demonstration of gaming technology in non-gaming is defense. And we're seeing this already, sort of simulations in a virtual sense are being used for governments to do better strategic planning and to have real-time tactical information of battlefields, for example. And that's a very specific kind of niche use case, but this significantly elevates the preparedness of governments from a defense standpoint. But that then boils and spills over into other areas as well. So it might be things like, we've just come out of a pandemic in the last couple of years. So pandemic preparedness is an example of where these technologies can get applied. Yet others that are perhaps a little less doom and gloom in a sense are things like e-commerce. We're seeing e-commerce move increasingly online, and we've already sort of seen this as gamers where microtransactions, they're controversial to an extent, but, at least the aesthetic ones that people are less concerned about, the non-pay to win ones, have really taken a foothold in the industry. Counter-Strike is quite an old game, and there are examples of the volume of microtransactions flowing through various versions of Counter-Strike. That's then moving even beyond pure digital assets into physical assets being bought and sold through a virtual experience, if you will. We're yet to see the first Amazon of the virtual realm. We saw retail move to web about 20 years ago, and there's yet another transition underway where there's an opportunity to try and test out products and experience them much more up close and in an intimate fashion before they're consumed. So much of these technologies certainly have a very serious implication. And with the goal of the metaverse being to move the internet forward into new mediums of interaction, to make them more intimate, personal, more intuitive, because ultimately we as human beings are most experienced with interacting in 3D physical like experiences. So the internet evolving into that realm means that the games technology that is at the forefront of making these kinds of 3D experiences possible, that's the technology being tapped to making these experiences realistic and feasible. And taking it even further, there are other realms like Industry 4.0, smart cities. These are sort of, at the cusp of breaking out right now, and they're the future of these kinds of digital technologies and the integration of also, hardware and sensors and so on to feed real-time data into people's lived experiences. And there's for example projects in the Middle East, like in Saudi Arabia, where they're building cities from the ground up to be smart cities, and that's certainly starting to take hold in other places like South Korea, for example. So there very much is this drive towards sort of industrial uses of this kind of traditionally games technology, and then movies, entertainment, like we've seen shows like Mandalorian that have shot, using game engines, and using virtual production. So certainly, this technology is starting to become games technology is starting to become very foundational for every aspect of our lives. And perhaps the last bastion that's the hardest to sort of crack is scientific research. But the future of scientific research is quite tantalizing when we think about the application of games technology. The accuracy is usually the problem. Scientific results need to be highly accurate. And games technology focuses more on being fast and fun and looking good rather than being accurate. But that bridge is also being crossed at the moment, and there's lots of work happening in a direction where we can get more and more accurate physics, for example, in a game for gameplay reasons, but that can be optimized further for us to be able to do scientific experiments in this realm and still get useful, reproducible, consistent results that can then be applied to the physical world. All of this is set to really transform every aspect of our lives, from the way new knowledge is added to our growing understanding of the world, to the way systems are engineered, the way our living spaces are engineered around us, the way our experiences are integrated into these living experiences, as well as the way entertainment is produced, the way it's consumed, the way countries are run and governed and operated. So it's quite a far-reaching transition or trend that's currently underway. It'll take a decade or more for us to fully realize it, but it is very exciting even in its early days.
Absolutely. There's so much going on in the space, and a lot of what we've been following comes from, major companies like Improbable, NVIDIA, and many others. And what we've seen is that there is a sharp rise in demand for these type of simulation technologies that allow people to build better products, to share and collaborate across the metaverse, and do things in 3D. So that way they can eliminate a lot of the mistakes before things go to production. So, yeah, like companies like Metagravity, I think they're going to have their hands full in the next few years, as people begin to, look for solutions that meet that demand. So wonderful news. I was going to ask you about this. We talk a little bit about the advantages your platform provides over these types of other companies like Microsoft, Improbable, and NVIDIA, and many of the other ones. So what makes your solution stand out?
Yeah, so that's a good question, and it is the billion-dollar question in the industry. I've actually been pondering solutions in this space for about 2 decades at least, and grappled with problems both in scientific research as well as gaming, I previously founded another company called Hadian, which is one of the other players in the space currently. That's still an ongoing company. And we worked in both science and defense as well as games. And now I've set up Metagravity, very specifically focused on solving scale. The bit that we haven't really cracked today is how do we make it easy for game developers to build games in the way that they are used to, right? How do you work within the engines? How do you simply write gameplay code the way you would work in Unreal or Unity, while at the same time enabling massive, incredible scale that is truly unlimited? So those are two sides to a problem that needs cracking. There are current approaches in the space. They're limited on these two fronts. They achieve a degree of scale, and I can say this having worked in this industry for a very long time. They achieve quite a high degree of scale, but then they hit certain hard limits, which then imposes constraints around how game designers work. They introduce significant production challenges for game developers and designers, in that they have to work in a completely new esoteric way to even achieve that limited scale. The third axis of this is the cost. These current approaches, they all become very expensive in terms of cloud compute very quickly. And they end up being much more expensive to operate than a standard session of Counter-Strike, let's say, right? And that's not really sustainable. If we want to really break through and make these kinds of experiences commonplace, we need to lower the bar in terms of adoption, in terms of the learning curve, the productivity, and in terms of the cost of operation, sufficiently to a level where there's broad-based exploration of all the uses of the technology. Because no one person, no one company, however large, can sit, say, in an ivory tower and work out all of the applications. It's a bit like the internet. It's a bit like decentralization with blockchain. It can only happen with broad-based global experimentation and development. But there is a necessary threshold you need to pass in terms of adoption for that to really start to take off, right? It's a bit like the age of exploration made sailing around the world somewhat tractable, so that started to happen. But fast forward to today, and with air travel, we travel further than any explorers of the great explorers in history, and we do that trivially. And you need to get to that level for us to truly identify and fill the dark zones of this world, this industry, right? So the uncovered, the unexplored parts need to be explored rigorously, and that requires sort of a very low bar of adoption and exploration. So to achieve that, Metagravity is working on the kinds of technology that fundamentally at a mathematical model level have no ultimate limits in scale. We can scale to hundreds of thousands, millions, eventually billions of users when we have that sort of demand. And we actually enable developers to work purely within the game engine to achieve that sort of capability. And that's the bit that makes us super, super unique. And then, of course, the cost factor, the cost of operating these kinds of large scale games on Metagravity's technology mirrors or is even lower than what you might see for traditional multiplayer gaming. And that's unprecedented. That's never been achieved before. Right? We can get well below the kind of cost of the usual multiplayer game experience, and certainly well below the cost of current solutions to try and scale up game worlds.
Excellent. And I know that one of these big things I remember reading about is that technology is limited by the laws of physics. So you'll see a lot of solutions as they scale up. They do kind of overcome these barriers, but then again, we have to find the correct use cases for these technologies. We also have to find ways that people can benefit. So there's the return on investment as well. This is something that's been preached quite often by companies like Lenovo. So as they develop their kind of like all-in-one enterprise metaverse solution, many of them are trying to find specific ways to create return on investment for the clients. So there's a lot of factors to come into play for that. But I know that, it's great to see the community, especially, involving your company as well, rise to those challenges and to tackle them as they happen. So yeah, wonderful. I wanted to also ask you, a little bit related to the future of spatial computing, especially in the cloud as well. So, why is cloud computing such a key component to successful metaverse experiences at scale? You mentioned a little bit about that. Could you go into more detail?
Yes. So cloud computing as a trend sort of really started to take off about 10, say 15 years ago. And The big advantage of cloud is the easy programmatic access of new hardware. So it's really, really good for prototyping. It's not the cheapest in terms of pure usage unit cost, but it's certainly the flexibility it gives and the ability to scale up and down in a very dynamic fashion in terms of resources you need, give teams of developers, studios, etc., a lot of flexibility in terms of how they develop and scale their technology. It also allows developers to overcome this sort of upfront cost problem that traditionally we would have had with on-prem hardware and data centers. But there's another aspect to cloud. So the initial aspect of cloud was very much, just, flexibility of having hardware and cost. But what cloud companies have had the economy of scale to achieve is also extremely robust, powerful, globally interconnected infrastructure that can then be built on and expanded to. No one company, unless they're extraordinarily large, can really justify this cost. And for example, Amazon with AWS being one of the prime movers in this space, did this very early on because they needed it for their application. And certain other companies like Microsoft and Google needed it for theirs. And so they had to build infrastructure. But then by opening that up to third parties, that became an extremely lucrative source of revenue to the point where Amazon's benefiting more from its cloud business than even its e-commerce business, which it built the cloud to help solve. So that infrastructure then becomes sort of the substrate on which other applications like Netflix would not be possible if AWS didn't exist, right? And similarly, the next step we take with cloud gaming or with gaming in general, with the metaverse, wouldn't be possible because the barrier to entry would be too large. A company would have to not only solve very risky R&D technology problems and risky market problems. They would also need to solve risky infrastructure problems at the same time in order to solve some of the things that are happening in the metaverse space right now. And you wouldn't get that. Like the intersection of those sets becomes a vanishingly small sort of niche, and it just becomes impossible. So cloud enables this broad-based exploration in the same way the technology we're building allows for virtual world scaling at low cost and with a great ease of use. So it really boils down to that. But then the other aspect of this is the trend towards, for example, edge data centers. So the cloud has then opened itself up to greater distribution of data centers across the world, which are sort of at the city level. Major cities have their own data centers. People connecting can get very low latency connections to a city. And then from there, you get across the cloud backbone, a ping back to centralized data centers in locations like, say, Northern Europe, for example, or East or West Coast of the US, and so on. So this then enables new types of applications to be built where you are using those hops between major data center locations and using the cloud backbone to build and optimize experiences that traditionally and historically would not have been possible. Right? So it really is about being that substrate that's an enabling technology.
Excellent. Yeah, great commentary on that. And I think, having that cloud computing allows, great access to basically all hardware, tablets, smartphones, and everything. So it builds that interoperability that is necessary for everyone to receive the same immersive experience, no matter what device they're using. So it also frees up those system resources to help people to, receive it if they have like a MetaQuest 2 or if they have, a Vario XR3. So it doesn't really matter, how powerful the device is. It can still have greater access to that with the cloud solution. So wonderful, wonderful. Speaking a little bit more about the technologies, how does Metagravity kind of leverage some of the emerging technologies like artificial intelligence, the Internet of Things, 5G, blockchain, and others?
Great. So I'll address each one of those separately because their implications for this brave new world for each one is quite unique. Where AI is really interesting is as we start to gain the capability to build these immense connected worlds, it introduces a new type of problem. How do we produce the content for the inhabitants of these worlds? It seems like an intractable problem. If you look at an MMO game, the biggest cost of the MMO game comes from the amount of content you have to produce in terms of assets and items and zones and maps and quests and various other things. And that's an extraordinary cost that's intractable for anything that's not a 100 million plus budget game. And that number has probably moved on quite a bit since, say, 10 years ago, when that was sort of the golden target of budget for even a modest MMO game. So AI introduces a approach to solving that problem. So generative AI has to play a role in creating that kind of rich content on every aspect, on every angle or dimension. This is music, it's 3D models, it's textures, it's even the concept art, it's audio, voice acting, for example, even real-time voice, it's speech, which models like ChatGPT introduced to the world in an interesting way, and then open source models like Llama and Alpaca are democratizing. These things enable these worlds to be built with rich content, but also for a lot of the content to be dynamically generated, which is necessary because when you think about an immense interconnected world where players have freedom, or inhabitants of, say, a metaverse app have the freedom to mold and shape and impact the world in a manner that's not possible in traditional gaming, you need real-time generation of new content that's very contextual and tied to what's happening at a moment in time, with the players involved and how that's shaping things around you. For example, a canned interaction in Skyrim was sort of the traditional model that every RPG historically has done. Skyrim is an exemplification of that. But there's also a demo recently built. I've seen this online. I'm sure you can Google it very easily. It's using a large language model to generate the speech for a Skyrim character, and then turning that into actual voice output so that you can hear them, and your voice input gets converted back into text and understood by the LLM. This is a really interesting loop, and there are others doing this. There's a Matrix demo, Unreal's Matrix demo mod that does this. NVIDIA showcased some tech that does this. So these are very interesting strands of technology that will make it possible to have these kinds of large worlds and have the content for them without making the content production an intractable bottleneck and constraint. So that's for AI. Now for IoT, smart cities are a good example of how these technologies will integrate. Smart city projects aim to have the physical world integrated with a digital simulation of it, and have that kind of real-time data feed, and even enable for digital-only interactions with the city in various ways. And that really needs to be tied into the IoT interfaces, the sensor data that's being collected, that is being fed through into cloud and edge data centers, being processed and being turned into inputs into shaping that virtual world model. And AI, again, can play a role in this, where you're turning some of that data as well into feeds that are deeply contextual, so the AI can understand things about the external world. It's like the eyes and ears of the world. It's a good way to think about it. 5G promises to significantly reduce the latency while increasing the bandwidth for how we connect cloud edge data centers right down to IoT deployments and installations together, and then democratizing the telecoms infrastructure. Telecoms infrastructure is expensive, and this is especially true of developing nations. It's easier for a developing nation to adopt the next leg in technology than it is even for a developed nation, because they simply can jump to the next step. And that's a very promising thing with technologies like 5G for also connecting regions of the world that are currently, perhaps to a degree, disconnected. from the rest of the world. And doing so with low latency and high bandwidth means that we all become part of this common fabric, this metaverse fabric that is being built today by the various different strands in technology converging. So I think this is a really exciting, interesting time, and the different strands are coming together in a way that is very sensible. It's working, and it will continue to work as we make innovations, but it's also serving an application that is currently needed. We're building Internet 2.0 is how I like to think about it. And these strands simply make that experience for what Internet 2.0 will be richer, but also it makes that aspiration feasible in a way that it wouldn't if the strands were not already being developed along different trajectories, converging at that common goal.
Excellent, wonderful. And I think with the implementation of all of these different type of technologies, we'll have these seamless experiences on the metaverse and make it a real thing, because that's what they do. They support and they add to the backbone of the metaverse. All the stuff happening underneath these different gaming experience or these simulations. These are critical, and they're always constantly growing and evolving with the platforms. So it's kind of like the behind the scenes look into what's happening with the metaverse. So yeah, wonderful. I really, really appreciate it. What's up?
Yeah, sorry, I was saying absolutely. I was agreeing with you. And spatial computing then sort of becomes the platform that these underpin, this backbone underpins and supports and makes richer and deeper and more meaningful and more capable. But then that's the piece that ties it all together to then be sort of that linchpin for creating the metaverse through a series of experiences that are profound and deep and interactive. So yes, absolutely.
Brilliant, brilliant. Lovely commentary today, and I do appreciate your time and attention for this, and thanks so much for sharing your insights.
Absolutely. Thanks for having me on. It's really good to talk to you and to sort of experience your show and participate in the conversation that helps shape, I guess, a lot of the thinking around the metaverse as we go forward. So thanks for having me on.
Brilliant. Yeah, so audience, once again, we've been speaking to Rashid Mansoor. He is the CEO of Metagravity Solutions. My name is Cureton, senior journalist for XR Today. And if you'd like to have more if you'd like to follow more conversations like this on the internet, please follow the XR News hashtag at Twitter and LinkedIn. So once again, it's XR Today signing off. Have a great day, and until next go around. Bye now.